Today, we're diving into something that might help. Data archiving in MySQL.
Right. It's a really important topic for anyone managing growing
Ah,
databases.
we'll be looking at some great insights from Kedar over at nitty-witty.com. So, our mission today is to really get a handle on what data archiving actually is, why it's important, especially for MySQL, when you should think about doing it, and crucially, how to do it, plus best practices.
Sounds good. Let's break it down. So, what is archiving? Think of your active database like your main work desk, maybe, or a closet you use every day.
Okay, I can picture that.
Archiving is like taking the stuff you don't need right now, old projects, winter clothes in summer, and moving it to, say, the attic or a storage unit, long-term storage.
So out of the way, but not thrown out.
Exactly. In MySQL terms, this means identifying and moving data like old system logs, maybe past transaction records, customer orders that were fulfilled ages ago, stuff you don't need for daily operations.
And where does it go?
Could be archive tables in the same database, maybe a completely separate archive database, or even outside systems entirely. Depends on the strategy.
The big problem this solves is database bloat.
That's the core issue, yeah. When your active tables get huge with all this historical data, queries slow down, backups take forever, you're using tons of expensive disk space, it just gets inefficient.
So archiving keeps the main database, the active part, lean and fast.
Precisely. Keeps it performing well.
Okay, so the number one reason is performance improvement. Smaller active tables mean faster reads, faster writes, which means a happier user experience, right?
Absolutely. Queries that used to take minutes might take seconds. It can be a dramatic difference, especially as tables grow. Imagine searching through fewer rows, it's just inherently faster.
Makes total sense. But you mentioned cost, too. How does that play in?
Well, storing massive amounts of data costs money, right? Especially on high-performance disks often used for active databases. Archiving lets you move that older, less accessed data onto cheaper storage.
Like slower disks or maybe cloud archive tiers?
Exactly. Local storage, cloud object storage. Options are usually much less expensive. Plus, smaller active databases means smaller backups.
Ah, so backup storage costs go down, and the time it takes to back up and crucially restore also shrinks.
Yeah, restoring a smaller database is way faster and less painful. Think about disaster recovery scenarios. Time matters.
Good point. And compliance. That's always a big one.
Huge. Many regulations, like GDPR or industry-specific rules, require you to keep data for a certain period. Archiving lets you meet those retention requirements without cluttering up your live operational database.
So you keep the historical data safe and accessible for audits or compliance checks, but it's not slowing down everyday work.
That's the idea. Compliance without the performance hit.
And its general maintenance becomes easier too, I suppose.
Definitely. Backups, restores, schema changes, even just checking disk space, everything's simpler and faster with a smaller, more manageable active database. Less risk of running out of space unexpectedly, too.
Okay, the why is pretty compelling. Performance, cost, compliance, easier maintenance. So when should people start thinking about this? Is there a magic number?
Huh, if only. No magic number, really. The general rule is archive data that's no longer actively used in day-to-day operations. But when that happens, well, that depends.
Depends on what.
On your specific business, how you use the data, definitely your company's data retention policies and those compliance rules we mentioned. You need to look at your access patterns.
So you need to understand your own data lifecycle first.
Exactly. The source gave some examples, though, which can be helpful starting points.
Like what?
Things like logs older than 6 months, maybe even just 1 month, though the author rightly points out. Maybe application logs shouldn't be in the database to begin with, but if they are.
Good caveat. What else?
Transaction records older than, say, a year, or customer orders that have been fulfilled and closed out for a while, ones you don't need for immediate lookups.
Okay, so stuff that's clearly past its active phase, but still needs keeping for some reason.
Right. The key is identifying that transition point, and you can automate this, which is often the best approach.
Automate based on time.
Yeah, like run an archival job quarterly or maybe annually, or you could even trigger it based on table size, perhaps. Automation makes it consistent and less prone to, forgetting.
Prevents that gradual bloat over time. Okay, makes sense. So we know the what, why, and when. Let's get into the how. How do we actually archive data in MySQL? The source mentioned partitioning.
Yes, partitioning is a powerful feature in MySQL, especially for large tables often targeted for archiving, like those based on dates. You can split a single large table into smaller physical pieces, or partitions.
Like having a separate chunk for each month's data, for example.
Exactly. You might partition a sales log table by month or year. This makes managing the data much easier. Queries that filter by that partition key, like the date, can be faster because MySQL only needs to scan the relevant partitions.
And how does that help with archiving specifically?
Well, once a partition contains only old data, say January 2023's data, you can manage that whole chunk. MySQL has a really neat command, exchange partition.
Exchange. What does that do?
It lets you swap a partition from your main partition table with an entire separate non-partitioned archive table almost instantaneously.
Whoa, really?
Yep.
Without copying row by row?
Yeah, it's a metadata operation mostly, very fast, very low impact. So you create an empty archive table that matches the structure, then you essentially detach the old partition from the main table and attach it to become the archive table.
That sounds slick. Much better than the old way.
What you mean, like insert into archiveable, select from main table where date, and then delete from main table where date?
Oh, that way.
That works, but as the source notes, it can be really slow and resource intensive for large data sets. Lots of I/O, potentially long-running transactions, locking. Partition exchange is generally much more efficient for this specific task.
Gotcha. So partitioning is a good strategy if you can plan for it. What about tools? Percona Toolkit came up?
Right. Peak Online Schema Change and PD Archiver, very useful tools.
How does Pete Online Schema Change fit in? Isn't that for, well, schema changes?
Primarily, yes. But it works by creating a new table, copying data over, and then swapping. You can use its where clause to only copy the data you want to keep into the new table. Effectively, the old table contains the archive data after the swap.
Ah, clever. So you use it to keep recent data, leaving the old stuff behind momentarily. The source had an example, right?
Yeah, something like archiving user logs older than a month using the log date column. It rebuilds the table keeping only the recent logs. You'd use dry run first, of course.
Always dry run.
Okay.
And Pete Archiver sounds more purpose-built.
It really is. It's specifically designed for archiving, deleting, or copying data chunks efficiently. It reads rows from the source, and you can tell it to insert them into another table, maybe on the same server, maybe on a different archive server, or write them to a file.
And then it can delete the rows from the source once they're safely archived.
Exactly. It does it in manageable chunks to avoid overwhelming the server. It's very flexible and, crucially, easily scriptable for automation via cron or task schedulers.
Automation again. Seems key. Okay, now for a really critical point the source raised.
Yeah.
Doing all this archiving, deleting rows, it doesn't actually free up disk space immediately. That sounds counterintuitive.
It does, doesn't it? But that's how InnoDB, the main MySQL engine, works. When you delete rows, MySQL marks the space internally as reusable, but it doesn't typically shrink the data file on disk and give that space back to the operating system.
So the file size stays the same, even with lots of deleted data inside, leading to die fragmentation.
Exactly. You get gaps inside the data file. The file itself doesn't shrink, and performance can even degrade over time due to this internal fragmentation.
Okay, so we archive the data, run the delete, but we're not done yet. We need to reclaim that space. How?
Two main ways mentioned. First is optimize table, your technical name. This command essentially rebuilds the table, copies the data row by row to a new temporary space, sorts it, rebuilds indexes, and crucially, the final result is a compact, defragmented table file that does release the unused space back to the OS.
But it sounds intensive.
It is. It can take a long time and usually locks the table, so it's strictly an off-peak hours maintenance window kind of operation.
Right. Not something to run casually on a busy production table. What's the alternative?
Similar effect with alter table, your per table name engine in InnoDB. Even though you're not changing the engine, this command also forces a table rebuild, just like optimize. Same caveats apply. It's resource intensive, locks the table, usually best for off-peak.
So rebuild the table one way or another.
Pretty much. The source also suggests using Kate Online Schema Change with an null alter like engine InnoDB. This tool is designed to do table rebuilds with minimal locking, making it a potentially better option for busy systems, but it adds complexity.
Okay, so step 1, archive delete. Step 2, defragment rebuild to actually get the space back.
Got it. Now let's talk best practices to avoid shooting ourselves in the foot.
Good idea. Planning first. As always, define exactly what data needs archiving, based on what criteria, dates, IDs, status, whatever. Define how often and where it's going. Validate that criteria carefully.
Don't want to archive the wrong stuff. What else?
Test, test, test. Always test your entire process. The archiving script, the deletion, the defragmentation on a staging server first. Mimic production as closely as possible.
Catch problems before they hit live data. Makes sense.
And before you delete anything in production, backup. Always take a full backup right before you start the process. It's your safety net if things go sideways.
Backup first, rule number 1. Okay, after it's done. Monitor performance. Did you get the speed boost you expected? Are there any negative side effects? Check things like replication lag if you have replicas. PeepT Archiver has options like check replica lag to help manage that.
Keep an eye on the system health.
And document everything. What was archived, when, where did it go, who approved it. Essential for audits, compliance, and just institutional knowledge.
And make sure the whole team knows, right?
Mm-hmm.
The source mentioned data loss on replicas because the strategy wasn't communicated properly.
Yeah, that's a crucial one. Everyone involved in managing the database needs to understand the archiving strategy to avoid conflicts or accidental data loss. Communication is key.
Okay, solid advice. What about common mistakes? What should we actively avoid?
Well, the big one is archiving without backups. Just don't.
Heard you loud and clear on that one.
Ignoring relationships is another. If you archive rows from a parent table but leave orphan rows in child tables because of foreign keys, you can cause data integrity issues. You need to handle related data properly.
Yeah, I need to think about the whole data model.
Also, over-archiving. Don't archive data that's still genuinely needed for regular reporting or analysis, even if it's slightly older. Make sure you understand the access patterns.
Balancing act there.
Failing to automate is another. Manual archiving is tedious and error-prone. And finally, as we hammered home, forgetting to defragment afterwards, you won't get the disk space benefits otherwise.
Right. Don't skip that final step.
Right.
Okay, so wrapping up, data archiving in MySQL using insights from nitty-witty.com seems like a powerful technique.
Definitely. Improves performance, saves costs, helps with compliance, makes life easier, moves that old, rarely touched data out of the active path.
But just archiving or deleting doesn't automatically shrink your database files on disk.
Correct. You need that extra step. Defragmentation via optimized table or an alter table rebuild, ideally during a maintenance window to actually reclaim the space.
So if you're listening and feeling that database pain, it's probably worth taking a look at your data. See what's old, what's infrequently accessed, and where archiving makes sense.
Absolutely. Maybe start small. Define a clear policy for one type of data, test it thoroughly on staging, back everything up, and then try it in production. Monitor the results.
Sound advice. So here's a final thought to leave folks with. Considering the sheer volume of data most applications accumulate these days, how might implementing a really well-defined archiving strategy fundamentally change not just your database performance, but your whole approach to data management and your long-term operational costs? Definitely something worth mulling over.